Assalamualaikum and salam sejahtera. We are from Group 1 would like to present Digital System Design Group assignment, and this presentation is prepared by Ahmad Faisal bin Kamaluddin, Ismail Laili binti Ismail, Nur Nabila binti Rosli, and Nurul Musliha binti Amani Nazri. Hi, my name is Nur Nabila, and I will explain to you regarding to our Digital System Design Group assignment. So, there are two parts in the assignment. For both parts, we are required to use the Xilinx ISE for Verilog modeling, simulation, and verification of our design. Before we go through that, what is Verilog? Verilog is a hardware description language, a textual format for describing electronic circuit and system applied to electronic design. Verilog is intended to be used for verification through simulation, for timing analysis, for test analysis, which is testability analysis and fault threading, and for logic synthesis. The question for our assignment in part 1, we have to design, simulate, and verify fully parallel 6-bit by 6-bit unsigned multiplier, digital circuit with full adders and half adders as a building block. So, to be detailed, AND gates are used for the product. The summation is done using full adders and half adders, where the partial product is shifted according to their bit orders. AND gates compute the partial products, and the addition of partial product can be performed using full adders and half adders. The 6 times 6 multiplier shown has 12 input and 12 output. So, for the diagram given here, this diagram shows the labeling and full diagram for this project. This project implements a 6-bit by 6-bit multiplier by multiplying each bit of the multiplicand by each bit of the multiplier to form the partial product. The partial products are then weighed and summed to get the overall product. This is the outline in the diagram below. So, for the diagram given here, X is the bit of the multiplicand, Y is the bit of multiplier, while B is the bit of the product. For the coding of multiplier 6-bit by 6-bit, our group decided to use structural modeling style, which means we are describe the system using basic components such as logic gate and adders. We have 6 half adders and 24 full adders in 6-bit by 6-bit multiplier. Well, that is the short explanation for our question in part 1. For the coding and simulation, I will pass it to my teammate, Nurul Musliha.
So that is the short brief for the assignment. My name is Nurul Musliha and I will guide you on how the coding for 6-bit by 6-bit multiplier will simulate. So let's take a look. But before that, I will show you the steps to do the new project. After create all the file that we need to use, and now we have to put the coding for each module. So basically on the display right now, we have the coding for half adder. Okay, and then we have the coding for full adder. And then this is the coding for multiplier 6-bit by 6-bit, which I have declared all the input as XY and output as P. Other than that, I also have declared the wire because I choose to do the coding for structural modeling style, and I also have the wire for carry and the wire for sum. Okay, as you can see, for this project we have around 36 AND gate that we use in this project. So I declare all the AND gate from G0 until G35, and then after that I assign the product 0 as W0 because W0 is at 0 and Y0. After that, I declare all the row, which I have first row, second row, third row, fourth row, and fifth row. And after that, we declare the AND module. The first thing that we have to do after the coding is done is we have to check syntax, which means we don't want any error before we generate post-synthesis and do the simulation. So we have to wait a little bit until the process check syntax complete successfully, display on our console part. Okay, after we got that, we have to generate post-synthesis simulation, and wait until process generate post-synthesis simulation model complete successfully. And after that, we can view our schematic, and this is the outer view, and this is the inner view of multiplier 6-bit by 6-bit based on the coding that we choose and do. So we have input as XY and we have output as a P, same as our coding declaration. So this is the full view of multiplier 6-bit by 6-bit. For test bench, which I choose Verilog test feature, I register the X and Y and register the output as the wire. And then for the initial input, I just use 3 value which I want to do as the simulation. And then after that, we have to click on the behavioral check syntax. Then we have to wait a little bit until we got the process behavioral check syntax complete successfully. And then we have to simulate behavioral model. And then this will come out on your display, and just click on the default side and then zoom in. Okay, so basically we have achieved the multiplier 6-bit by 6-bit and we got all the true value for the equation. And then this is the output in the binary, and this is the output on unsigned decimal. So for the part 2, I will hand it to Ismail Aili and Ahmad Faisal. So that's all from me. Thank you.
Okay, I will present about part 2. The question for part 2 is to design, simulate and verify a synchronous digital system that detects and recognizes your student ID as password that can be used to generate an output signal. The student ID is entered to the system sequentially and synchronized to the master clock for proper operation of the system. The system is expected to generate an output logic high for 3 clock cycles if the ID sequence is detected correctly. The system will then return to the wait state where it waits for a new sequence to be entered by user. Use any of the student ID from the group members in this design. You are free to add any additional features to your system as deemed appropriate. Next, I will pass to Ahmad Faisal. Thank you.
As you can see in the previous part where my friend Isma talked about the question part 2, and right now I will talk about the coding, the circuit, the timing diagram, and the test bench of the part 2. Okay. As you can see here, for this module, we name it as a combination logic circuit underscore Faisal underscore with my cut method in it, which is B022110027 with the bracket of port, which are clock, E as an enter, RSTN as a reset, C and T as a count, valid pass, and alarm to declare each of the port as an input or the output. Okay. If you look at the line of 23 until 27, you can see the declaration of each name, such as parameters. Each function has to set a certain value, for example, like n equal to 4 and width equal to 2. Other than that, clock is set, E will be our input and the rest will be the output. At the line of 29, I use a procedure block to make the system operate repeatedly, depends on the certain triggering input. And as you can see here, inside the procedure block, I use if else to create program selection that can operate if it performs the desired statement. Okay, there's a lot of selection of statement here, else if statement, and if none of these are enabled, the else statement will be activated, which are count equal to 0, alarm equal to 0, and the valid pass will be high for the time being. Okay, for the next coding is the module of password log system underscore Faisal underscore B022110027 with the port of reset, storage pass, enter, valid pass, and counter and alarm. At the line of 23 to 27, where I declare input, output, and wire, something like reset, enter are the input, check as a wire, and the output, and the others are outputs, which are valid pass, alarm, and counter. Okay, as you can see here, next coding, I will make check assign not in the bracket storage pass X or gate operator with interpass. It means here if the data that insert in this both section are same, the output will be 0, but due to the not operator, it will become 1. Okay. Okay, next I use the name of the previous coding that I talked about to combine with this new coding in order to create the circuit exactly as we want it to. So this is the circuit that has been generated based on the code that we create, where the combinational module combined with the password log system module. For the combinational module, It is a part that where the process to generate outputs which are unlocked, valid pass, and counter depends on what input data is. And for the parcel system module, if you see the outm, that is a box where the process the input, either the input data is same or not. Alright, and pretty much that's it for the circuit. And next part I will talk about the test bench and the timing diagram. Alright, the test bench. In order to get the output of the timing diagram, we have to declare the input either it's low or high. To do that, we must customize our coding to make it work. The initial procedure block purpose is to determine each input both high and low. The reason why it's initial is because it executes only once, and that is very perfect to test the timing diagram. This coding must be customized in the module of password lock system module. And first off, I will declare this for input as shown in the coding. Here, such as reset and enter is 0, while the storage path and enter path will be our desired data, or we could call it the password. Storage password is the set password, and the enter password is the password that will be entered by the user. Okay, and then we will test each input to observe a certain output, and that we will see in the timing diagram. Okay. So this is the timing diagram we get where the input path is fixed with the data of my ID metric. The input path will be inserted with several data to test the output in order to observe the function of the coding. Input enter will frequently activated for a short time, and if activated at the position of the wrong input data, the count will be added into 1. And if it reaches the frequency of 3, the output alarm will go high. The process will keep going until the reset is triggered. Subsequently, the output of valid path will high if the input data is correct. And that's it for the explanation of question part 2, and I will humbly hand it to one of my friends, Isma, to conclude this video presentation.
As a conclusion, we have achieved the objective for this group assignment. First, we got to learn about how to set up and perform simulation, also verification for a moderate complexity digital system design using Xilinx VIVADO or Xilinx ISE FPGA design tool. Other than that, we also learn how to communicate effectively through effective report writing or oral presentation. That's all from our group. Thank you.